We now turn to substitution effects. Substitution effects arise when opportunity costs change. When we investigated income effects in graphs 7.1 and 7.2, opportunity costs did not change. All we experienced was a pure change in income, with the slopes of the budget constraints remaining the same. A change in opportunity costs means that the slopes of the budget constraints are changing. We begin by imagining that my brother and I take a week-long vacation in the Cayman Islands. When we arrive at the airport, we can decide to either rent a car or to take cabs as we get around the island. Renting a car involves paying a fixed fee, but then a relatively low per-mile fee because all we have to do is buy gas. Taking cabs, on the other hand, doesn't involve a fixed fee, but it does involve a higher per-mile cost of getting around the island, because we don't just have to pay for the gasoline, but we have to pay the fee for the cab on a per-mile basis. The first budget constraint we illustrate is then the budget constraint where we've already paid the fixed fee and are renting a car at a relatively low per-mile cost. If we instead choose to take taxis, we'll have more money to start out with, because we don't have to pay the fixed rental car fee before leaving the airport. Thus, the vertical intercept of our budget constraint if we take taxis is higher than the vertical intercept for the budget constraint where we rent the car. However, each mile driven will now cost us more in a taxi than it would in a rental car. Thus, the slope of the budget constraint for the taxi is steeper than the slope for the budget constraint for renting a car. The rental car fee can then be read off as a vertical distance on the vertical axis of our graph. If we take cabs, we don't have to pay any fee. If we take a rental car, we have to pay a fee before we ever get out of the airport and drive a single mile. Thus, the difference between the vertical intercepts of the taxi budget constraint and the rental car budget constraint must be the rental fee we paid in order to start driving the rental car. Suppose that I chose to rent the car, and my brother chose to take cabs. I therefore chose the blue budget constraint, while he chose the magenta budget constraint. We then do the best that we can, given our budgets. If we have the same tastes, we can use the same map of indifference curves for the both of us. And if we made different choices over budget constraints, it must imply that we were indifferent between renting cars and taking cabs. Thus, our optimal bundle under our two budget constraints must lie on the same indifference curve, otherwise we wouldn't have been indifferent between choosing to take cabs or renting a car. We therefore illustrate a single indifference curve that is tangent to both the steep magenta and the shallower blue budget constraints. My brother is therefore doing the best that he can, given his magenta budget constraint, at bundle A, while I'm doing the best that I can, given my blue budget constraint, at bundle B. Since bundle A must necessarily lie to the left of bundle B, because it lies on a steeper portion of the indifference curve, this implies that my brother will necessarily drive fewer miles on the island than I will. He will also consume more other goods on the island than I will. We will say that my brother and I both enjoy the same real income, where by real income we mean that we enjoy the same level of happiness given our identical tastes. The only difference between the two of us is that he faces a different budget constraint than I do. His budget constraint has a steeper slope and therefore a higher opportunity cost for driving around the island. As a result, he consumes fewer miles driven, while I, facing a lower opportunity cost for miles driven, will consume more of those. This is an example of a pure substitution effect, an effect that causes a change in behavior for identical tastes solely because the two individuals are facing different opportunity costs, while at the same time enjoying the same real income.